Good afternoon, everybody. I'm just going over the notes that took place for your class either yesterday, the 17th of September, or today, the 18th of September. So the first thing we talked about were angles. Angles are formed by two rays. As you see, the blue highlight was one of your rays, BA, and the green highlight, that's BC, that's your other ray. The vertex, which is also referred to as the turning point, that's the common endpoint for both of your rays. So it turns out both rays, BA and BC, have the common vertex of B. That's your common endpoint. So, and since that's the case, then since B is your vertex at your midpoint, you're always going to put your vertex in the middle as the middle letter. So when we name our angle ABC, again, B is your vertex that's in the middle. Now, if you named it CBA, that's okay too. That's not wrong. As long as your vertex is in the middle, you're good. But then over here, we had to flip the A and the B. We had to flip that order because A is your vertex, so that's in the middle. Unlike here, where B was in the middle. So we named this angle BAC, or you could have named it CAB. Same thing. Again, vertex in the middle. And sometimes, let's say there might be a situation where you just only have one letter. Now, if you look at all these four examples on the bottom, it turns out there's only one letter. You can use that single letter if there's no other points to name your angle. So in this case, this is angle A for your acute, your right, your obtuse, and your straight line triangle, or regular angle. Sorry, I said triangle because I'm thinking 180 degrees. Now, anytime you see the lowercase m, that's a measurement. So example, for this first angle over here, measure of angle ABC is 60 degrees. And since 60 is between 0 and 90, that's an acute angle. And that leads us to four types of angles down here. Acute, 0 to 90. Right, exactly 90. So even if it's like 89.999, that's not going to work. Or 90.0001. It has to be exactly 90, no questions. Obtuse, that's the angle between 90 and 180 degrees. And your straight line angle, that's exactly 180 degrees. Nothing larger, smaller, not no 179.999 or 180.0111. No, it's exactly 180. This next slide, let's talk about, again, naming. The turning point is K. Your sides are the rays, so KJ, that's one of them, and KL, that's your other. So those are your sides, those are the rays. Name the angle JKL or LKJ. Notice K, that's your vertex in the middle. You could have also named it angle K, which we drew a diagram here, so pretend J and L didn't exist. You still have your turning point at K. And this angle looks it gets more than 90 degrees, but less than 180, so this is an obtuse angle. Now, congruent angles with the same measurements. So for instance, we have measure of angle RST, which is highlighted just in the yellow part. It's equal to TSV, which is highlighted in light blue. Those angle measures are equal. Therefore, we can say RST is congruent to TSV because they have the same measurement. Now, sometimes congruence is noted by way of arcs in your diagram. So, and also there might be a tick mark, hash mark, because if in the case there's more than two angles, then we know which angles are congruent to each other. And sometimes you might see hash marks as well. That's fine. Now, here, this is going to lead us to where measure of RST plus the measure of TSV, and it's going to give us the overall measurement for RSV. So RST plus TSV gives us RSV. And that's going to be what we're going to talk about next. Angle addition postulate. Two adjacent angles, that means they share a ray or side. Then we can add their measures to help us find unknown angles. So, for instance, RST, that's the one in green, and TSV, the one in purple, they're adjacent. Adjacent because they have that common side. So, if you use a highlighter or something, or color pencils, if you notice how, if two colors are touching the same ray, it means they're adjacent angles. S is your vertex, your turning point for both RST, TSV. They're saying measure of RST plus TSV equals the overall measurement of RSV. So that's the idea of the angle addition postulate. All right, now for this problem, RQT was our overall angle. Overall angle was 155 degrees. So given the angle addition postulate, RQT is equal to the sum of RQS plus TQS, or SQT, could be the same. So since the sum of these two angles we know is 155, we have to combine the two terms 4x minus 20 plus the 3x plus 14. So we set up our equation, 155 equals 4x minus 20 plus 3x plus 14. And now we combine like terms. So for this part right here, we needed to combine like terms. To get the 7x minus 6. And then at this point, solve for x. That takes place here. That's a two-step equation. Step 1, add 6 to both sides. So when that happens, 6's go away. And then 155 plus 6, 161. Divide both sides by 7, because that's the opposite of multiplying by 7. Divide by 7, so we do the opposite of what we see, and then 161 divided by 7, 23. However, we're not finished, because then you need to replace x with 23 over here. And you also need to replace x 23 here. So, and then from there, we will then be able to substitute for x, and then solve, and then simplify or solve by way of the order of operation rules. Which, the first one, 4 times 23, 92, minus 20, 72. And for the second one, 3x plus 14, 3 times 23, 69. 14 more gives us 83. So these were the two angle measures we needed. So if you just gave me 72 for RQS, but you have to tell me 72 represents a measure of RQS, and 83 measures the value for TQS. And I should have put degree symbols. Then check to make sure, add your two numbers, 72 plus 83, we get 155 for a total. That's for the overall angle between the ray RQ and QT. So 155, I'm sorry, is the overall measure from the ray RQ to the ray QT. And then once you add them up, 72, 83, 155. All right, numbers add up, we're good to go. Always check your work. All right, number 8. Similar to number 7. So DEF is a straight angle. Straight angles from the first real notes of for today. Straight angles 180 degrees. So DEF is 180 degrees. Since these two angles are adjacent, they both form a straight line. We're going to talk about that definition in a minute. You add up your two sides combining like terms, and then solve for x. So first part, we set 180 to equal 11x minus 12 plus 2x plus 10. 11x, 2x gives us the 13x. Negative 12, positive 10 gives us negative 2. And now we solve for x. First, you add 2 to both sides. So we have 182 equals 13x. Divide both sides by 13. 14 is your response. Then you substitute. So then substitute here. And oops, right there. So we substitute 14 for x. 11 times 14 is 154. Minus 12, 142. And then, so that's a measure DEC, 142. Then, for CEF, x is replaced with 14. 3 times 14, 28. Add 10, 38. So 38 is the measure of CEF. So we should write 142. That might be another way to think about, as you complete work, where should you write down your results? So technically we're finished with this problem, but always make sure when you get your angle measures, add them up. So they total the overall grand total, which in this case 180. The answer is yes. Measure of ABD. Now, the arcs, DBC, CBA, and they have single hash mark just in case. That tells me they're congruent. And sometimes what will happen, I made a mistake earlier. Sometimes you'll have hash marks. Sometimes you're going to have multiple arcs as well. So I will talk about that one later on. So we have the arcs for angles DBC, CBA. We know that these angles are congruent. So DBC, you could say, is congruent to CBA. Since the angles are congruent, you set them equal to each other because they're the same. So therefore, you set the two expressions equal. Now you solve for x. So step 1, subtract 8x on both sides. Now you could have added 5x. Subtracted 5x on both sides. That could have worked too. And you would have had positive numbers, but that's okay. Your next step, so you get negative 3x plus 5 equals negative 16. Add 5 to both sides. Therefore, you have negative 3x equals negative 21. And then divide both sides by negative 3. So your two negatives become positive. And negative 21 divided by negative 3 becomes 21 divided by positive 3. And we get x to 7. Again, similarly, once you find your value of x, substitute into each expression. In this case, DBC, 5 times 7, 35, plus 5, 40. And CBA, 8 times 7, 56, minus 16, 40. Now, the last thing, we needed the entire angle measure from DB all the way to BA, or from BA all the way to BD. So you need this entire, and then in the end, whoops, in the end, it turns out both angle measures are 40, DBC, CBA, and then add them together. Measure of angle ABD is 80 degrees. You can say ABD or DBA, same one. Okay. Now this one's a little slightly different. It might be in your notes. I'll give you one hint. ABD is overall. So that's your overall. And then we need to look for ABC. And then DBC. So that's our goal here. You can try it. We didn't cover it, but no worries. So that is one way so you could try this. So I'll just give you the hint. You will set ABD, that's your overall, equal to ABC plus DBC. And it's similar to the previous problem. Substitute and then solve. This one, you need to find both ABC, CBD. Now, talked about this briefly. We're going to talk about it again. Anytime you see this little box, that tells us that's a right angle. So right away, we know that from here to here is exactly 90 degrees. Now, since this from EBA is 90, then you could say ABD is also 90. So there's your hint. Those are 90, 90. But now you know that the sum of ABC plus CBD, so I'll write that down. So given the diagram, ABD is equal to ABC plus CBD. And we know that ABD is 90, so 90 will equal ABC plus CBD. That's all I'm going to give you. You can try it if you want. If you don't, no harm, no foul. Okay. Here's an example of angle bisector. The angle bisector, which is blue in this case, that's going to be our, you should say, this is going to be our midpoint M. Okay, sorry about that. So, angle bisector, there's your point M. And then, let's say this is B. And this is A, C. And then similarly, well, we did ABC, M, but notice again, arcs. And then I'm going to show you something in a little while. Differentiate complementary angles. sum of the two angles equals exactly 90. You might see it in this form, but if not, you could always say angle 1 plus angle 2 equals 90. And then angle 1 plus angle 2 equals 180. So that's for this example. Adjacent angles, they're the angles that are side by side. They have a common vertex. So for this example, notice how you have your angle, the purple one, and it shares a side with the red. This opposite side opposite. Let me start again. The angle, red angle. Notice how the red angle and the purple angle are represented by the same ray. That's an example of adjacent angles. Similarly, when you have the blue angle, the green angle, again, sides touch, highlight, boom. That is an example of adjacent angles. Now, give you another example. Well, I should label. I have the habit of labeling my angles. We'll use now, angles could also be labeled by numbers too. So do be aware. There may be some activities where we will number the angle. So do beware. That is in, let's say P R Q. And similarly, W X Z and then this one B Y. Okay. Now this part. So the linear pair of adjacent angles is non-common sides. So the non-common is going to be this bottom line here. That's your non-common sides. The common side I'm going to highlight. So the two angles that they're adjacent because they share a side. But the non-common sides, see this green arrow going to the left, blue arrow going to the right, those are opposite rays. Therefore, this is a linear pair. Now, next part, vertical angles. So this is where, in fact, I'm going to probably use, this is the part where I'm going to do a double. So therefore, sometimes with angles, you're going to see if it's more than one pairs of angles, you can tell this pair with the single arc, those are congruent. And then let me fix this a little so it looks more like a double arc. The ones over here, red, since it's two arcs, that means these angles are also congruent. And usually another way, you could always highlight too. So you can highlight, for instance, there you go, blue where angles are going across, they're vertical. And then here, this blue one going across the point, these two angles up and down are equal. Now, linear pair postulate, two angles form a linear pair. They're supplementary. Well, that's because this distance right here is 180 total degrees. So that's automatic supplementary. So this entire, in red, from blue line to the green line, or the blue ray to the green ray, that's 180 degrees. And then vertical angles are congruent. Again, with the diagram, angles across from each other. Not next to, but just across. Okay, thank you so much, everybody. We'll probably do a few more angle activities to help you prepare for your quiz that's 1 week from today, or 1 week from yesterday, either the 24th or 25th. All right, thank you, everybody. Take care.